Brown. I'm from Cochran Supply. It's my boss, Scott Cochran. And we're here today to do a little bit of an overview and intro to BAS systems. How many of you here are familiar with BAS on a high level? So, nice show of hands. Let me first talk a little bit about Cochran Supply, where I come from. We're a building controls distributor based out of the Detroit area. We service mostly the Midwest, but our reach is growing. We have 6 locations in Michigan, Ohio, and Kentucky, and we're expanding into Indiana. We have a large inventory, and we have a training center that we recently built where we train on all of the products that we sell, mainly Niagara Systems, BAS, and if you're interested, check out our website. We've got a lot of classes coming up. We start all the way at the bottom from what is HVAC, all the way to a very advanced level training on computer networking systems and analytics, any sort of software that we sell. Okay, so.
A little bit about you.
A little bit about me, not just the company I work for, right? So, my name's Kim, I'm 34. I have been in this industry since I was 19 years old. I started as a receptionist at Cochran Supply, worked my way up. Cochran really believes in promoting from within, and I've received a lot of training along the years in this industry, and I'm now the technical service manager. I run a team of 5 IT people and developers that not only do the technical support for our company, but also do custom development as well. And I work with this guy who's the president of the company and an industry leader. And
Kim, do you like the BAS industry?
I do, honestly.
Why do you like it? Please tell everybody.
When people ask me what I do, it's really hard to describe what it is that building automation is. So I kind of try to relate it to the thermostat in your house and say, okay, you can connect to that with your phone, you can control everything going on in your house, same thing for commercial buildings. Then the light bulb goes off. What I love about it is, as a young person, I'm very concerned about the future of our planet. Energy efficiency is huge for me. I really want to see future generations have a planet to grow up in. I love being able to affect that in everything that we do. So I'm really big on the energy side. It's big for me.
And what are you going to school for now?
I'm going to school right now to get my degree in information technology and web programming. Finally went back to school at 34. Took a little time off, but I'm a single mom, and trying to balance that is always a little tough, but I'm managing.
Now, why are you studying IT, Kim?
I am studying IT because that's the future of everything. Everything is web-based. Everything is going towards IT. Having a background in that is only going to help in the future. I really believe that mobile phones are, everything that we're doing, handheld devices, that's not going away. Everything is going to become more granular. Everybody wants information in an instant in their hand at any given time. We want to be able to go on and see what's happening. If we're in traffic, I can go on Google Maps and say, well, what's going on? Of course, there's a crash. And I can see that right then instead of having to just wait and sit there in traffic. I can get off on the next exit because I can see that information instantly. So to me, that's really important. I'd like to have a background and know what's going on so that in the future, when technology continues to evolve, we'll be able to speak that language a little bit.
Great, thank you. Sorry to
No, it's all right.
impromptu you there.
No, it's all right. So, a lot of you have heard of BAS, so we're going to just go to the next slide here and kind of say, what is BAS? So, the Wikipedia definition is the automatic centralized control of a building's heating, ventilation, air conditioning, lighting, and other systems through BAS. So basically, we're able to tie everything from a building, all the way from the heat, the lights, elevators, security, life safety systems, all into one computerized control network. So for this places importance on the occupants of the building as well, comfort and life safety are very important factors to people, obviously. We want to go to a building, we want to make sure we feel safe, and we want to be in it and feel comfortable. So it's a little chilly in here. Wish I wore a sweater. That's the kind of things that building automation systems can do for you. The occupant level of the room goes up, the temperature can go down, so that we're not sitting here in a heat box. Right. So, like I mentioned before, that's the purpose, to provide safety and comfort. We tile these buildings together into one computerized central system. So a lot of systems that are being put in, you put them on a network, go back to a server, or some sort of computer that can aggregate the data and do something important with it. So it's not just having the data and controlling the temperature. It's what do? We can use this to make decisions about how the building operates. Like I mentioned, if there's more people in the building, we can adjust the temperature. We can make sure that it's a safe place for everyone as well through security systems. Tie those into BAS. Somebody can swipe their card, enter the door, it unlocks, it turns the heat on in their office, so it's nice and comfortable. It's the way that they like it specifically. Yeah, sure. Now Scott is going to kind of go over a little bit of sure.
Hi everybody, I'm Scott Cochran. I'm the president of Cochran Supply. And for those of you who read Automated Buildings, I've been reading it for 20 years. It's kind of been one of the staples for myself in terms of learning what's going on out there. And I think of Ken as probably one of the great minds the industry will ever see, Ken Sinclair. So I've been working with Ken for a while now, a couple years. I've been writing for him, and we've been collaborating on quite a bit of the technology, which I'm thrilled to do. And Ken asked us to cover this topic with you folks about basic BAS. And just kind of going back on what Kim said here a little bit. So building automation, what's really going on there is the services within the buildings are all becoming digitized, right? Whether it be a security service, life safety, HVAC, electrical distribution, you name it, it's got a computer on it, okay? The computer is what makes it an automation system, because the computer thinks and can make decisions without you having to be involved. You can set up criteria, or you can set up a schedule, and the computer will make that system do what you told it to do, and you don't need to do it, right? Not only will it tell it what to do, it'll keep track of what it's doing, and it'll allow you to go back and see what happened, right? So you can go back to the computer and check out, hey, what happened to that air handler? It stopped working at 8 o'clock, what failed, right? And that data will be in that system for you. So the purpose of it, really, the core purpose of these automation systems, I mean, in a real raw sense, is to make the building run better, right? So the purpose is to comfort, safety, security delivered reliably, at a cost effectively, right? That's the purpose of building automation. And we as an industry in building automation, as Kim mentioned, we're dealing with this systemic change from pneumatics to the digitization of everything. Like every piece of a building now has a computer on it, and the maintenance folks need information off of all of it, right? So the BAS industry is evolving rapidly. There's more and more devices being introduced every year, okay? Now, for those of you who understand BAS a little, how many of you would say that security and life safety are a part of a BAS system? Okay, we had a huge argument in my office about that. I agree with all the people who raised their hand. That is correct, and as time goes on, you'll see the difference between those services break down more and more, because the digitization of it, those computers are able to do more than just an HVAC system. They're able to do more than just than a security system, right? And so deploying them against multiple services within a building brings economies to it that make it more competitive, more cost effective. So we're definitely seeing, and of course, all these services really roll into the experience that the building operators have, and the occupants, which means that it is really part of a bigger system. So. Okay, so how does it work? So there's a lot of ways to describe how a building automation works, but what I'd like to kind of do is to help you just understand how do the computers work within a BAS system. And I think by understanding that, it may give you a better sense of how a system operates. So at the equipment level, at the light switch, at the rooftop unit, we're going to have what we call a standalone controller. So that's like a little mini computer dedicated to running that that rooftop unit, okay? And when we say it's standalone, that means that we can just give it a direction and it will run without anything being connected to it, okay? So we can just tell it maintain set point, and the little computer makes sure everything works right within it to maintain set point. We call that standalone digital control, okay? And a thermostat would be one of those objects, right? So, but as we know, those computers, while they're running the sequence of operation or they're taking care of the equipment for us, and while it is running standalone, some of these can communicate outside of the controller itself, okay? So they have a thing called a communication protocol or a network connection that allows us to get data from that control maybe to another control or to an interface. Those controls we call networked, okay? Those are network controls. They can sit on a network, communicate with each other, communicate to a global computer, and give you the ability to do mass set point changes or apply a schedule against hundreds of units, right? Because now they're networked, they communicate, okay? So those network controllers can also act standalone, and most network controllers do. Because why? Because they're running a piece of equipment that needs to operate regardless of whether that equipment is on the network or not. So if I have a rooftop unit and it's controlled based on set point and the network comes offline, the unit should still control set point, okay? Standalone, right? Networkable means I could maybe send a global set point into it, okay? And change that set point, but the actual sequence of running that set point will be within that controller itself, okay? So the network controllers, that was the DDC day. Around the advent of products like Niagara and others that are more software platform, more agnostic to the different products that can be tied to it, we started to look at this thing called a global control. So a global control would sit on top of the network of controllers and control potentially all of those, give all those network controllers their information. Kind of like, it's the leader of all the network controllers would be that global controller. So it can look at all the network controllers and determine if there's a problem and enunciate it. It can also bring data in from all the network controllers to be analyzed against each other. So I can compare this rooftop to this rooftop to this rooftop. I can also centralize all my alarming from that equipment back to these global controllers and share them in a single spot. So what happens is when we do the really big buildings, so let's say we have 100 VAV boxes, we bring that to a global controller. But my job has 500 total VAV boxes. So I may have 5 global controllers to talk to, each one to 100 VAVs. And then believe it or not, I network, I'm using it on my hand. I network the global controllers back to a server, and I tell them the global controllers what to do. Which means I can send one set point out to 500 VAV boxes with that architecture. Does that make sense? Okay? And that's how that's the core of it, right? Is to bring it up to a central point where we can make central monitoring and control reality for a large group of equipment, buildings, systems, bringing it all together at one place, okay? And that's really how it works. It's really just a matter of these little computers and what their role is, right? Their first role is maybe to run the equipment, communicate, and then maybe upstream. My job's to to control the whole building, and then my job's to control the whole campus. Well, each version, each piece of that hardware software has a role, and in BAS, each one determines how it sits in the architecture. Okay. So let's just kind of go through. I like to call this a day in the life of BAS data. So So what happens is in BAS, and we'll just talk about mechanical systems, is you're going to have mediums out there like temperature, lighting, things like that. They're going to be on traditional sensors. Those sensors will typically report back to what we talked about, that standalone controller. And that standalone controller is probably controlling a piece of mechanical equipment like this. The mediums, or the different sensors that come into the controllers, they're going to come in typically with an electrical impedance type of signal, right? Like a 4 to 20 milliamps, 0 to 10 volt DC, 4K ohm resistor, you may hear that, right? The sensors that tie into the controllers are going to have a specific range that is associated with them. So if you're replacing, say, a temperature sensor for this controller, you have to know what type of communication that temperature sensor has. Is it 10K? Is it 4 to 20 milliamp, right? And depending on that, you'll choose that temperature sensor to match the range that the controller's used to looking at. The controller will take multiple inputs, lots of temperatures, pressures, humidities, status, right? They all come into that controller, okay? The controller has a thing called outputs. So with the information that it has, with what you told that computer it should be doing, it will then drive that unit's outputs, things like dampers, turning fans on and off, setting a speed on a VFD. Those will be the outputs that the controller does to maintain whatever you ask that controller to do. And all of that is self-contained to the unit itself typically, right? You'll find the controller is usually mounted in a panel on the side of the equipment. And all the wires from that equipment come back to that panel and are terminated in it. If that is a network system, that panel is going to have a communication network going out to other rooftops, other mechanical equipment in the building with it. Okay? So the data starts here, it goes into the controller. The controller usually keeps the data here for the most part, right? It's running a sequence. As long as it's running properly, a lot of the data just sits inside of the controller. But things like alarms or things like trends will be put out on the network and can be captured by other software on that network, like the global controllers, to be utilized for other purposes. Okay? So this temperature, for instance, for this equipment is used for the set point. It's used to generate alarm if it goes out of a threshold that you set up, right? So that same temperature can create an alarm. That same temperature may be monitored and stored as a history, so I can go and check on that unit later. And that's all just one piece of information on the system. That's just temperature, right? Okay? So at the lowest level, each one of these will have a purpose. That purpose will get regurgitated by the controller, and the controller will share different functions to the BAS network depending on how it operates. Now, for the longest time, the network that we've been putting these controllers on has been 485 and Lonworks for the mechanical industry. That has changed. Going forward, this year and forward, you're going to find that that network that you're plugging the controllers to is becoming IP-based. Okay? The industry's moving from 485 primarily because there's a lot of reasons why, and I don't want to be the guy who said why. I'll just tell you that all your major manufacturers, Honeywell, Johnson Controls, Siemens, Schneider, many others in the BAS industry, for the first time this year are going to offer a full line of IP controllers that you can put in, all the way down to the VAB boxes. And with that, the architecture is going to change. The old architecture was the controllers on a 485 to a global controller. Global controller takes you from 485 to Ethernet. And that's where we'll get the data is on the network, right? Well, now the architecture is changing. 485 is going away. IP controllers, guess what they don't need? They don't need a global controller. Anybody know why?
Speak the language already.
Correct. You're already on, the global controller in a lot of cases was just taking that 485 and turning it into IP for you so you could bring it up to databases. Well, if the devices aren't on 485 and they're already on IP, I'm not going to add that overhead, right, to just aggregate the data and add hardware. Instead, I'm just going to put that software on a server on that network. And I'm going to do all those functions through a service running on a server instead of adding more global controllers to the job. And that's going to lower the cost of deploying these IP architectures because we're not going to put in as many controllers. We're going to put in less, and we're going to add more software. So the data, again, going back to the day in the life of the data, like I said, most of the data stays at this level, but a lot of the data can be moved outside of the building automation system, and there's two main places where that data will end up going. The first place is, typically in a BAS system, you will have a server or a place, what we call a front end, or a graphical user interface, right? So the first place where that data ends up is on that, as a data value for that graphical user interface. But what we're finding now in the newer systems is now a lot of what's going on is that the data is moving outside of the network and going out to the internet and is being utilized by cloud services as well. Whether it be for analytics, to look at optimization in terms of energy for the equipment, things like that, or it may be used for a remote monitoring contract for 24-hour immediate service, things like that. So the data from the BAS doesn't just stay local. It actually will leave the building a lot of times and be used to offer a different service that brings value to that system that got installed. At the end of the day, believe it or not, the BAS data is the most valuable thing that the BAS system has, believe it or not. We've seen it more and more. Why is that? Because the data is what drives the decisions which makes the building run better or not, okay? And data, what is it used for? I kind of talked about automated control and monitoring. That's the traditional method of what we do with the BAS data. So a traditional BAS system, those network controllers will report back to potentially a server, which is serving out a web page. And you can go to that web page, and if it's a mechanical system, you'll be able to maybe look at all of the status of all the equipment in a graphical format, okay? You could go in deeper to that equipment and actually potentially control aspects of that equipment. So you could potentially click on the discharge air set point of the air handler and modify that set point, right, as a way to service that unit. So not only can you look at everything within the graphical user interface, there's going to be certain aspects that you can control also. Okay. That same graphical user interface is going to have logs, trends, things like that built into it. So you'll be able to go into the equipment, say that air handling unit, click on it, and go to a trend on what it was doing within that graphical user interface as well. Graphical user interfaces used to be dedicated to computers. So in older systems, you may walk in and you'll go into the mechanical room and you may see 3 or 4 computers on little wobbly desks. And each one is a graphical user interface to a different digital system in that building. Okay? It's very common to see that today. As we move to platforms like Tritium and other things that brought that web experience, we've moved away from having the PC or the computer on the desk, and we've moved over to just a web interface. So it's almost exactly like what they were looking at the desktop level, except now it's in a website, so they can use their mobile device or their laptop or their iPad, whatever they want now, to get access to that information. And that's where most building automation systems today will offer web-based graphics, right? Okay? And that's where you see a lot of that. Graphical user interfaces are very powerful for the contractor, for the installer, and for some of the building maintenance people who get heavily into how the operation of the system works. But the graphical user interface typically is not useful to somebody like a manager or an engineer, somebody looking for a quick snapshot of information. The way we originally designed it with the amount of equipment we had to put on, there's menus and floor plans and lots of data, right? So because of that, to get quick information in front of people, we've seen a lot of companies start developing a thing called dashboards, okay? So what a dashboard is in a graphical sense, it's an aggregated data set that comes from all the, so if you're, let's just say, for instance, a dashboard for a building. It could be, the dashboard could be the average room temperature throughout the whole building would be maybe an indicator of something. Or the number of alarms affecting the building as a whole, just the number of alarms. We'll dashboard that, right? And what a dashboard does is you put little, aggregated pieces of information on the graphic, and then they click on it. If it's kind of like looking at the news articles. Okay, this one's interesting to me. I'm going to click on this, and then we give them the rest of the detail from the dashboard. Okay. You're a facility manager. You got 35 buildings on this campus. Each one of them has a BAS mechanical system that's on this integrated system. You sit down at your desk in the morning. Do you want to go through 5,000 VAV boxes? No. You just want to know the 6 that are wrong, right? And any other major indicators. That's what a dashboard does for these people, is it makes their job easier. It just gets to the point of the information that they need when they need it. And frankly, these can be designed in traditional BAS systems, and they bring a huge amount of value to people, okay? In recent years, we've seen the uptick of analytics and fault detection inside of BAS systems or as a part of BAS systems. So what we're talking about there in terms of that is when we do control algorithms, we use things like PID loops and things like that, which are, it's a method of doing control, okay? And they're pretty advanced algorithms in some ways. But what we don't do as an industry, or we weren't doing, is we weren't really looking at the output of what we were creating from that. So in the mechanical industry, there's a lot of ways to do things. And if we can pull the data from a lot of different examples and compare it against each other, and then write some algorithms against it, we can start to do things like predict failures. We can figure out ways to make equipment more efficient that wasn't efficient before, that nobody thought could be more efficient. We can find anomalies in buildings that nobody's looking at. Pretty common use, right? These are the uses of analytics today in buildings, okay? And what analytics basically does is, going back to the day in the life of the data, all that data gets collected, it all gets rolled up global controller up to a database, and then they run an analytic engine on that database, and they write rules in the analytic engine that ask for information about that data that we didn't have before, okay? A lot of good products out there, and we're seeing a lot of new analytic services coming out. So we're seeing companies that have analytics on a cloud where you can go into a BAS system, attach a, for lack of a better word, a Raspberry Pi to it, suck a bunch of data up to an analytic cloud, and present energy efficiency reports to your customer at a very low cost, very quickly, very effectively, right? Analytics drive better decision-making about buildings, and they bring a lot of value to the end users. And so we're seeing, again, that market's exploding. With analytics comes fault detection and diagnostics, and you're already seeing it in your smart equipment today. So instead of just telling you, instead of just, the equipment's not working, it tells you why the equipment's not working. It looks at a series of values within it. It runs analytics against it, and it comes up with the reason why things aren't happening, right? That's fault detection. A lot of BAS systems, the old BAS systems, this would be something that would be built into the controllers. And so like an economizer telling you that the damper's stuck open, right? That was around for a while. But what we're doing now with fault detection is more at a bigger scale, like being able to look at hundreds of buildings and come up with algorithms of fault detection for equipment before the equipment fails, come up with factors that cause the failure, and this is thousands of points of data now that they're able to bring together. So you're going to see this is a big, big part of the industry, and it's going to keep growing into the BAS industry for sure. Of course, BAS is used for trending. A lot of us know that and use it today for that. But what we're finding today is we're going to be moving from trending to query. This all, of course, as we know, is going to the cloud. I mentioned tagging, but what we're finding is, give me my phone. We talked about this in the last session, but there's no question that our lives are changing with the mobile devices. I mean, I think everybody's probably got one with them today, right? And what's interesting about building automation systems and mobile devices is in the commercial space, they're really not together yet, right? We talked to some folks from Europe where it is converged, but you don't see a lot of offerings in terms of mobile interfaces to building automation systems, right? Apps and whatnot. Now, if you want an indicator of what's coming to building automation, all you got to do is like go to your favorite like home store, like a Home Depot or a Lowe's. Go to the building automation aisle and check out how many app-driven devices are sitting there, okay? Because every single one of those smart devices for your home, can anybody come up with one that doesn't come with an app? No. Now in Europe, they're putting apps on buildings pretty frequently now. So you're building a 40-story condo complex in downtown London. The occupants are going to get an app. They're going to get the 52nd Street building app, which is going to allow them to control their comfort, maybe their lighting, and maybe get to additional services for that building, right? And that's what's happening in Europe. You're seeing the apps actually be put on projects. Here in the States, and here in the commercial building sector, it's been a slow migration. But I believe because of the residential stuff hitting the market so much and the demand for it, I'm a distributor, and I will tell you, we're selling a ton of those Wi-Fi residential stats to commercial buildings, a ton, okay? Why? Because the services that are brought through these cloud connections and these apps are things we can't get in the commercial buildings today. So they're there. And so anyways, what's really fascinating though about the apps is the coolest thing about the app is the app obviously gives you the person interfacing with the information and experience. But the other thing that the app does is the app inside your phone allows me to get information about you. So I'm able to figure out who you are. I'm able to figure out where you are because there's location services. I know what altitude you're at. And if I want, I can count your footsteps. And I can pull all that data back into a building automation system through an app. So we're seeing new services are coming from this, right? Like, has anybody heard of indoor positioning systems? That's the ability to locate an asset in a space through the ability to track them, their mobile device. Your mobile device, I can see where you are in the building. I can put that on a floor plan. And based on where you are, I might be able to enable a new service. So I walk up to that door, I know you're at that door, I know you're authenticated to open that door. I'm going to biometric scan and open that door, all through an app, right? Okay? The occupant, in some cases, they're going to be able to walk around the buildings and the temperature will automatically change just because we know where they are in the building. We know that they're the one in charge of set point, so we're just going to, wherever they go in the building, the set point's automatically going to change, okay? And this is allowing us to functionally integrate these services in a building in a new way and change how people interact with the buildings. That gets into that building emotion thing that Ken and we were talking about earlier today. A lot of owners are driving for cooler systems to attract top talent, to keep good people, and to be more business efficient, okay? So we're moving out of selling these systems in traditional ways into selling them for HR reasons, for recruiting reasons, things like that. So the future is all the data in the building will be accessible in the building as it is today, But there will also be new services enabled for that building based on connecting it to the clouds, okay? And that's the most exciting part of the industry. That's what we focus a lot on, is where that's all headed. Okay. So, what are the typical benefits of BAS? Where, what is it, when you're a typical owner, what are the cores of selling it? Really, when BAS started for mechanical systems, it came back to efficiency, energy efficiency, right? It's the simple concept. If I let a unit run uncontrolled and I don't put a schedule on it, I'm wasting a ton of energy, okay? When I put a BAS system on something, I start turning it on and off. That is a huge energy savings. We've seen buildings where they didn't have a BAS and they put a BAS, save as much as 40% of the energy the next year, because most businesses are really just operating 10 hours a day if it's a typical business, right? So and you got a 24-hour window here. So if I'm turning equipment off 14 hours a day, think about the benefit of that. So at the very, very core, the building automation system is there to turn equipment off and save energy. It's the basis of what it does. And if a BAS system is not in place or it's overridden, guess what there is? A huge energy inefficiency there, okay? We work with hundreds of contractors. I can't tell you how many can walk into a building and within minutes deduce whether a BAS system is operational or not, and how many of them can go and sell energy savings to an owner and not add anything other than get the BAS system operational in the building. It's a great way to save energy. A lot of construction in terms of BAS goes in and it doesn't have service after, okay? It just kind of gets thrown in and then the maintenance group takes over the BAS system, and these are kind of complicated computer systems, and in a lot of cases the owner's staff is not able to continue to maintain that computer side, and so they give up on it. And when a hot cold call comes in, what do? They go to the room with the wrenches and they override it, right? And over time those BAS systems get overridden until I can't tell you, it's sad. The majority of BAS systems today, if they're more than 5 years old, are probably running at 50% of what they were meant to. You're lucky. Just because that's the way the industry kind of operates. Okay? And what happens when that happens? The efficiency of the building goes, right? So that's one of the cores. That's the core of BAS, is to get in, and if it's running properly, the building is going to be more efficient. My dad started at Honeywell. He spent 40 years in the industry. He always told me this, and he is right. Are you ready for this? This is a true this is very true. The most comfortable buildings are also the most efficient, believe it or not, okay? The mechanical systems that are designed for a building, if controlled properly, it's engineered to be efficient, if controlled properly, okay? But when we don't control it properly, the energy just goes crazy, and so does the comfort. Because the system has to work to keep up with things then. If it's not, it's like think about a good football team, okay? New England won yesterday, right? Didn't they? I think they did, right? What do the Patriots do better than anybody else in the NFL? I mean, this is my opinion. What I think they do better than anybody else in the NFL is they're always a good team. I mean, Tom Brady's great, but think about how many different running backs, how many different wide receivers, how many different defensive ends they've had, right? And it's not like they just go and get the superstars. They get these people I've never even heard of. And yet here they are again in the AFC Championship game. Why? Because it's a team. Everybody has a role, and if everybody does it right, we win. It's the same with the BAS system, right? Those controllers need to be on a network that's managed properly. They need to be set up properly. And if everybody's working right in the BAS system, guess what happens? Everybody's comfortable and the building's efficient, okay? One of the other things you're going to see in the next couple of years is, again, that argument of BAS, is it a part of life safety and security? We can argue that. But when it comes to lighting and electrical distribution, which includes the power going to the building, there is no question that is a part of BAS. There are some states in the union, California being one, where they've passed a thing called Title 24, which will force, by code, every lighting control system to be managed by a building automation system in a commercial building of a certain size or bigger. I don't know the square footage. That's going to be energy code in California now, okay? So those of you in the mechanical industry, just so you know, BAS does include lighting control, and the two are going to be converged. Why? Why? Because there's no reason to have two computers telling the same schedule. The lighting and the HVAC and the scheduling of it, they go together. It goes with the operation of the building, and there's a lot of synergies of pulling that together. Not just from the standpoint of less stuff on a project, but also from the standpoint of division of duties and how contractors work on projects and the ability to make them work right, okay? So the lighting industry comes in and they put in a lighting control package. It gets set up by a rep. It's done by an electrical contractor. The BAS guy does the same for a mechanical system, right? I mean, you have two fully different trades, two fully different channels, running full tilt going into the buildings. When we do this, there's no question. It's more cost effective. The projects go better. And the owner at the end of the day has a better working system because now they're not maintaining two of those computers. They just got to keep one together, okay? So lighting is a part of BAS. It's going to continue to grow into it. For those of you in the mechanical control industry already, I'll give you the good news about lighting is it's fairly easy. A lot of it's on off and stuff like that. I'll give you the bad news about lighting is when the lights don't turn on, everybody goes crazy. So it's not like when they're just hot or cold. It's a little different. It's like they go crazy. So, and they can't open the building and all sorts of stuff. But no question that a benefit of BAS is being able to put that mechanical electrical system on the same schedule and optimize those energy savings that way. It's just a very simple thing to do and a great way to save energy. There's a lot more advanced strategies with lighting and HVAC now and security and others. Lighting is the most pervasive way to get a sensor technology put into a building because if I can embed sensors into light fixtures, then I can put a whole sensor network in a building by just putting in new light fixtures, right? And those sensors can then be used to know things like whether somebody's in a room or not, so I know whether or not to turn the lights on, or I know whether or not to change the set point, things like that. So they're quickly coming together to make those sequences work properly. One of the other things I learned in this industry is, working with performance people in terms of energy, is a lot of people go and do big energy projects and save themselves hundreds of thousands of dollars in energy. But you know what they forget to do? They forget to meter themselves before they started the project so that they can show the boss the actual savings, right? So the electrical distribution systems and the metering data that's available from the power coming into the building, again, that should be a part of a BAS system. How are we going to save energy if we don't even know how much energy we're using? For any of you in the energy business, the first thing you should do is sell them a meter and baseline their building. I mean, if you're not, then again, you're really opening yourself up to be scrutinized, to not have the right data, things like that. So when it comes to a benefit of BAS, it's super easy to tie that meter data in. A lot of the electrical distribution equipment that gets put in, they can't afford the computers and stuff that go with it. But a lot of that switchgear is actually a communicating controller that we can put on one of those networks back to a global controller, and we can pick up that usage, okay? If you have the ability to, the next session, Scott Bain from Tritium is going to be here. He's going to go into 101. Scott's going to talk about the different protocols and different ways that the standalone controllers talk on that network. He's going to talk about that. And there's a lot of protocols that they built into electrical distribution equipment that literally we're just a little plug away from having that energy data from. Not to mention the fact that now with the new Rogowski coil and the rope type CTs, I mean, to throw a meter on a building is not a big deal anymore, okay? Like, we're not shutting down factories like we used to throw a meter on, right? There's a lot of cool options on how you can pick up energy. But it should be a part of every BAS system is the energy of the building, okay? By having those together, it's a huge benefit to the building owner. Another big benefit of a BAS system is business efficiency. So by being able to aggregate that data together, put it in a central place, we can eliminate the need for a lot of people to look at it. By being able to automatically alarm things or automatically dispatch resources based on information in the building, again, we can create more efficiencies within the building to get things handled quicker at a lower cost. As time goes on, the business people are looking at things like set point and productivity. So by being able to hold a certain set point within an area, they can guarantee a higher level of productivity, okay, for the actual space that the work's assigned to. We're also seeing now with like lighting control systems, the ability to track where people are in the space and actually start to report back to people about space utilization as a service. To say, okay, Mr. Building Owner, you have this 100,000 square foot space, yet only 10% of it's actually being utilized, and start to create that. So they can make better decisions about how they use their square footage, right? Okay. I think that the business efficiency side is going to turn to building emotion, like what we talked about in the last session, where not only are we putting in these systems to drive the cost down, but we're also putting in these systems to improve the life or the experience of the occupant in the building. So we're moving from not just doing lower cost, but actually the cool factor, right? Millennials want to work in a place where that's cool. And building owners are now designing building automation systems so that they can offer that. There's like, for instance, there's a company that got bought by Siemens last year called Comfy. Comfy was some innovative young people. They came up with the idea of within a space, they have an app where people can vote for their comfort, whether they want it hotter or colder. They aggregate the voting and then give feedback back to the maintenance group to change the set point or have it automatically happen. That's to improve the experience of the person in the building. That's the driving factor, is just the experience of the person, okay? You're gonna see more and more products geared towards that, geared towards driving the occupant experience regardless of what the building is to make that better as one of the driving factors for BAS systems. Another benefit of BAS systems, of course, and this is the most obvious one, is it meets your basic code and safety requirements, okay? So you have an energy code, you have a ventilation code, all that stuff. The automation system not only can help you achieve that, it also will monitor it for you and give you feedback for your reporting of potential codes that you have to follow with reporting. One of those might be if, let's say you have a LEED building, right? LEED buildings require reporting of its energy usage on an annual basis to get the LEED certificate. Your building automation system can generate that reporting for you, okay? That's why they give you extra LEED points with the BAS system too, so. Now, life safety is all code driven. Not much to be said about that, but security systems are not. Security systems, there may be some codes, but for the most part, security systems and their benefits are based on the social responsibility of the building it's in. So for instance, a K through 12 school today has, there's a lot of funding going towards that mitigating the threat of shooters going into the school, right? Now that's not code driven. That's the social responsibility of the schools knowing that this is a growing problem, right? So a lot of your security systems you see on buildings are built around the responsibility of that building's goals, right? Depending on what it does. So where life safety is almost 100% code driven, security is almost 100% based on the responsibility of the people who are setting it up. And mechanical, I'd say it's a mix. So, because Because in mechanical, we have a thing called value engineering. No, I'm kidding. No, sorry. But I won't go off on that tangent. Anyway, so yeah, the typical benefits really are energy and comfort, right? All the different business efficiencies, and now the ability to offer this emotional side to the people, make the workplace better. And then, of course, it's there to just do the basic job it's supposed to do, which is meet the code and safety requirements on some systems. So. Okay, cool. All right, so now there's a lot more to BAS, and I could keep talking. We're getting towards the end. So I guess at this time, I'd like to open it up for any questions or any topics that you want me to us to dive into. Yes, please.
Is there a clear return on investment for installing BAS?
The question is there a clear return on investment for installing BAS systems? The answer is yes. If there's no BAS system, okay, depending on the equipment, your payback could be pretty dramatic, right? There's different ways of calculating it, but there's no question that turning off running equipment will save a ton of energy. And it just depends on the equipment to get those payback formulas, right? I'll give you a good example, like at a granular level. You know, like we've seen it, in terms of payback, a BAS system alone maybe not the answer, but sometimes like a BAS retrofit with variable frequency drives, right? So it's not just putting controllers on sometimes, it's actually, because now I have this digital controller, I can put a VFD on and I can change the sequence to save that, you know, not only turn it on and off, but ramp it up and down properly as well. And there you get into even more savings. So yeah, there's just, you could just go forever on that side of it. Any other questions? Yeah.
So what is the sweet spot of building size? So, you know, if we think about large buildings, 100,000 square feet and above, that's only 1% of the stock, okay? The 90% of the stock is 5,000, 10,000 square foot or less. Are we saying, is there a sweet spot of building size where BAS makes most sense? Do you need it to be at least, I don't know, 10,000 square foot and above, or any number like that?
Yeah, it's a great question. The question is like, where do you really want to put network controllers in a building or not? You know, like what's the square footage versus just going with like standalone equipment, right? Controlled by a thermostat. So in the old days, right, that was a big question because we were really like binary back then. It was either we were all in or not. So, you know, back then it was like, well, building about 100,000 square feet or greater typically is when we really need to think about networking that equipment for optimization. But what's happened in the last couple of years, so they put in the standalone equipment, but they put a Wi-Fi stat in there. It goes up to a cloud and we can aggregate that data back, which is exactly what you do with the BAS system. So what we're finding is that those light commercial opportunities now are being served by a different type of BAS system, right? It's being served by a thermostat that goes up to a cloud. It's not an on-prem network controller with a front-end type of situation, but the result to the owner is the exact same. Because at the end of the day, the guy, he's still getting access to all his thermostats on a mobile device, right? Which is what the BAS system did for him. So again, those lines are really being blurred with these Wi-Fi stats and these other cloud-based products we have to offer. I dare to say almost everything you're going to put in the next couple of years would be deemed building automation. Just because it's digitized, it communicates, it can be aggregated. So. Next question? Yep.
You threw a slide up a little while ago with all of the individual components that you would typically network on a BAS system. Would one assume that device would have to be a smart device with an IP address over the controller?
So, you know, you talk about like smart equipment and whatnot. The first step to smart equipment is that it's got a controller embedded in it. It's digitized, right? Now, we talked about standalone control. So that digitized unit is going to be able to run its control, okay? Whether or not that, you know, how that controller communicates with other network devices kind of helps you understand like how, like, so in other words, there's a high probability that you're going to have many network devices that are connected to each other, right? Those devices don't need to be IP. Currently, most of those devices they put on a 485 network, okay? Like you hear BACnet MSTP, or you hear about LonWorks. LonWorks is 2 wires, but that's not IP, okay? And that is the majority of the industry is still going out on 485, things like that. But where we're headed, the next evolution this year is a lot of controllers now are coming out with IP right there instead of 485. And when those controllers do have IP, it's exactly what you said. You need to get an IP address and a drop to put that, you know, to connect to that. So, but the majority of the market is still putting in 485, which is not IP. 485 is like 3-wire, right? It's like 18.3 shielded type wire. Ethernet, Cat5, right? That's a different type of physical wire, okay? By the way, the next session, Scott Bain, is right here. That's Scott. Is he in the room? Mm-hmm. There he is. So if you can handle another hour of this, Scott's actually going to go into deep about those protocols, what they do, and he's going to the next level of this stuff for us. So. Not that deep. Yes, next question.
Construction-related question. Can sometimes be a disjointed process. You know, electrician's doing his thing, mechanic's doing his thing. Sometimes they talk, sometimes they don't. Depending on GC, and if it's not driven by the owner, you know, the concept you talked about providing BAS makes a lot of sense. But sometimes the electrician wants to do what he knows, and the mechanic wants to do what he knows. Can you describe situations where you've seen that work a little bit better, and what level you have to get to?
Yeah, it's a great question. Converging lighting control and BAS together in the construction community, that is not easy. The construction community does not like to change. I'm just going to tell you, every one of those projects that we've seen in terms of not code-driven have been owner-driven. The owner wanted it and they got it. It is an upstream battle right now with that because the lighting industry they don't want to give up their control business to the BAS people, but they don't go to market like the BAS people. So, you know, it's never easy, but again, I've seen it happen very, you know, in the code-driven it works and owner-driven it works. Now, that Title 24, you all can look up your own states. You'll find that each one of your states has an adoption date for this type of code. I think like 30 of the 50 states in the union have a date for their Title 24 coming to fruition in their states. When that happens, commercial buildings of a certain size will require that the BAS system controls the lighting controls at that time. So right now, owner-driven, future code-driven. Got time maybe for one more? Yep.
If I install a fire alarm system, I can program that panel to do 10 points to 1,000 points, and I can see how it's controlling the mechanical system, the sprinkler system, open doors, close doors. Who sells a panel that I can purchase and program myself to do a 1-family building, a 40-family building, without calling Honeywell, without calling Johnson Controls? A basic system.
Well, there's a lot of them, and I sell them, so yeah, I can sit here all day and tell you the good and bad of them all. So I don't want to do any commercials here, right? I'm here for Kent Sinclair and Automated Buildings, but if you want to stick around after, we'll be happy to give you some recommendations. Folks, there's just so many different systems out there, so many different options. It's a great time to be shopping for it. I'll just say that, right? A lot of neat stuff out there to look at these days. But if you are getting into the BAS business, if you are evaluating new BAS vendors, and you do think about scaling up in terms of doing larger projects, I highly recommend that you make sure that they do have an IP offering. That would be my one recommendation right now, is to hold that as sort of a criteria, is that can I put it on a network or not, or is it all 485? Because that's just an added cost in the future if it's 485. No reason to include that today. So, but there's a lot of options. Okay, great. So here's a couple of sites. Kim and I use Wikipedia just for the definition. And for those of you who don't use Ken's sites, Automated Buildings, it's fantastic. And for those of you, one of my favorite parts of Ken's site is he's got this really cool timeline. So if any of you want to go back and reference times in BAS history, for anybody who's like a geek like me about BAS, it's really cool. So Ken's site is fabulous.